Hi all, this is page 2, I guess page 3 and 4 of the Chapter 10 test review on trigonometry for Algebra 1B. So here we'll cover questions 11 through 19. Notice in 11 through 13, and I even marked it here, that these are not right triangles that you're dealing with. And if they're not right triangles, that means you're going to have to use your laws. Okay, so no more SOHCAHTOA. Here we're going to be using our laws of sines and cosines. Okay? And to decide which is which, you can try either one. Whichever one you think is easier, try that one first. I usually think law of sines is easier, so I look to see if I have any pairs. If I was going to pair these up, that 4.8 would go with that angle there, but I don't have the angle. The 5.2 would go with this angle here, but I don't have that angle. And the 135 would go with the x, but I don't have that side. So I don't have any complete pairs here that I could use to set up that proportion, which means law of cosines is the way I want to go. Okay? So, to do that, here's my formula. A squared equals b squared plus c squared minus 2 times b times c times cosine of A. So to start us off, remember that with law of cosines, you always want to put the A next to your variable. So if I'm looking for the x here, this is now going to be called side A instead of x, which makes this angle across from it angle A. And then B and C are just the other two, and it doesn't matter which is which. So I'm going to fill this in as a squared equals 4.8 squared plus 5.2 squared minus 2 times 4.8 times 5.2 times cosine of 135. Pardon me if my handwriting gets a little crazy. I have a 2-year-old climbing all over me at the moment. Okay. And then with these ones, because this is all numbers, you can just type that all straight into a calculator. So give me just a second to do that. When I type that all straight into a calculator, I end up with a squared equals 85.38. And then remember, that's a squared. What I really need is a. So to get rid of that square, I'm going to take a square root. And I end up with 9.24. And that would be your final answer. Okay, let's look at number 12. Number 12, again, I'm going to have to use either law, sines, or cosines. But notice in this one, I have this side 15 that's across from the 32-degree angle. So that means I'm going to be able to use law of sines here. So let's set that up. When I set that up, I'm going to put the 15 with the 32-degree angle. And so that'll look like this. Sine of 32 over the 15, which is the side length. Remember, when you're doing this one, you always want to do sine of the angle. You never want to do sine of a side length. And then you would say that equals sine of x over 21. Now, we didn't do a whole lot of these in class where the x was up here with the sine. You can still solve it exactly the same way, and then I'll just show you what changes about that at the end here. So I would go ahead and cross multiply. So I would do sine of 32 times the 21 and divide by the 15. And when I do that, I end up with 0.7419. And some of you might be looking at that and saying, well, that answer doesn't make sense. Well, remember what that's equal to. 0.7419 is equal to the sine of x. It's not equal to just x, it's equal to sine of x. What you're really looking for here is the angle. And anytime you're looking for the angle, you're going to end up having to use inverse trig. So I would do second sine of 0.7419. Okay, so second inverse sine of 0.7419. And again, that's anytime you end up with something equal to the sine of x. To get x, you do an inverse. And you end up with 47.9. I think you could probably round that to 48 degrees. Okay? So that'll do it for number 12. Let's take a look at number 13. Now there's something kind of weird about number 13, and I'll explain it when I get to it. But if you did it on your own and you think that you got it wrong because the answer came out strange, you might be right. So again, to look at this in terms of sines and cosines, the only pair I have is this one here, this x angle across from the 15. And because I don't have a number here for x, I'm not going to be able to set that up with law of sines. So law of cosines it is. Which means if x is my variable, I want to call that angle A, which would make the side across from it side A. And then the B and the C are just your other two. Now this is going to be one of the ones that's a little more complicated with law of sines. Law of cosines. So this time I have a number to put in for A, so I'm going to say 15 squared equals 9 squared plus 12 squared, so that's B and C, minus 2 times 9 times 12 times cosine, and this I'm just going to leave as an A because this is what I'm solving for. This is what I don't know. And then I've got to work in three pieces. I've got to do 15 squared, I've got to do 9 squared plus 12 squared, and I've got to do the 2 times the 9 times the 12. Well, 15 squared is 225. 9 squared plus 12 squared is 225. And 2 times 9 times 12 is 216. And remember from here, I'm not allowed to combine these two. I can't do 225 minus 216 because the 216 and the cosine of A are joined together. So instead I have to solve like an equation. To do that, I'm going to subtract this 225 because that is a positive 225, so you can get rid of it with subtraction. Now this is the part that might freak you out a little. Over here, 225 minus 225 is 0. And then over here I'm left with negative 216 cosine of A. Now because this is multiplication in here, negative 216 times cosine of A, I would divide by negative 216. And 0 divided by 216 is 0. That cancels. And so now I have 0 equals cosine of A. This is a similar situation to what we had up here. We had something equal to the sine of x. Here I have something equal to the cosine of A. So I'm going to do the inverse cosine. I'm going to do cosine negative 1 of 0. And I'll tell you, that's kind of a weird thing that came out to be 0. It's not incorrect. It's totally right. But usually that's going to be a decimal of some kind. And when you do that, you come out with 90. And that is correct. That's a 90-degree angle. What you just found is that the measure of this angle, if these were the three side lengths, would have to be 90 degrees. Now I know in the picture it doesn't look like that. Remember, you can't always trust what you see. Truthfully, I think I just randomly picked some numbers that turned out to be a right triangle without meaning to. But just keep that in mind, that you can't always go by what the picture looks like. You have to go by what the math tells you. Okay. Last up here, the exact values. Remember, exact values mean to use the unit circle. Okay, so anytime you see exact values, you're not touching your calculator. Exact values are unit circle questions. Okay, so cosine of 150. Well, cosine of 150, that's going to match up with the 30-degree coordinates, except the x-coordinate is going to be negative. And the x-coordinate is your cosine, so this would be negative square root of 3 over 2. Okay. Sine of 240. See, sine of 240 is just before 270, and so that's going to match up if you followed that rectangle around with the 60-degree marking, except it will be negative down in that third quadrant. So sine of 240 would also be negative square root of 3 over 2. Tan of 270, let's see, I'm going to move this over here. tan of 270, that's going to be, the coordinates there, remember, are 0, -1. So when you go to do tangent, you do sine divided by cosine. So -1 divided by 0 is undefined. Okay, so for tan of 270, it's undefined. Cosine of 585. Cosine of 585, because that goes more than one whole time around the circle, I would have to subtract 360 from that. So I'm doing 585 minus 360, and I get that 585 is really like a 225-degree angle. And 225 is in the 45-degree position down in the third quadrant. So down in the third quadrant, both coordinates are negative. That means the answer to that is negative square root of 2 over 2. Okay? Sine of negative 135. If you take negative 135 and add 360 to it, because remember you can always subtract and add 360, that one also comes out to be 225 degrees. That's a little bit of a coincidence. But if you went 135 degrees backwards, you would land at 225. Again, that's in the 45-degree position, and both coordinates are negative, so that also is going to be negative square root of 2 over 2. Those last two answers are exactly the same. Now, tangent of 315. 315 is in the 45-degree position down in the fourth quadrant. So down there tangents are negative. But the tan of 45 is 1, so tan of 315 is going to be the same but negative. So tan of 315 is -1. Okay, that got a little confusing, so let me just run through those again real quick. Cosine of 150 is negative square root of 3 over 2. Sine of 240 is also negative square root of 3 over 2. Tan of 270 is undefined. Cosine of 585 is negative square root of 2 over 2. Sine of 225 is negative square root of 2 over 2. And tan of 315 is -1. All right, it's time for the dreaded word problems. I would guess that probably for most of these problems, the hardest part is going to be just setting up the picture. Once you have the picture drawn, probably most of you will know what to do, or at least have a guess as to where to start. So, we have a plane flying at 42,000 feet. Now, I will tell you that my artwork is not good normally, so drawing on this iPad like this, it's probably not going to be terrific, but I think you'll be okay. So here's my airplane, okay, and it's 42,000 feet, which means that off the ground, from here to the ground, is 42,000 feet. Notice how I'm just going piece by piece out of the word problem to set my picture up. And they're flying toward the airport, which I'm going to put somewhere over here. That's the airport. So right now the plane is flying like this. Okay, the plane is flying along this path. But they need to turn and head towards the airport. So I want to turn and head this way. Okay, and here's the ground. The ground down here, there, and it tells us that along the ground we're 324 miles away. And what I'm looking for is the angle of descent. So like I said, if the plane is flying along this path right now, but needs to turn to head towards the airport, the angle that I'm trying to find would be this one right here. But through alternate interior angles, that angle is going to match this one. And if I make it that one, then I have it inside my triangle and I can use trig. So I have 42,000 feet over here as my hypotenuse. I'm sorry, that is my hypotenuse. Again, I have a 2-year-old climbing on me, so pardon me if I seem distracted. Okay, sorry, let me try that again. So, if this is my angle here, this side, the 42,000, that's my opposite. And then this side, along the bottom, since it's right next to the angle, would be my adjacent. But before I go setting up any trig ratios, I need to deal with a little problem. Here I have 42,000 feet. Here I have 324 miles. So before I can proceed, I need to convert one into the other. I'm going to go ahead and convert everything into miles. So that means I'm going to take 42,000 and divide by 5,280. So 42,000 divided by 5,280 leaves me with 7.95. So here, instead of 42,000 feet, I'm using the 7.95 miles. Okay? So, if I have opposite and adjacent, that would be tangent. So I'm going to say tangent of x, which is the angle I'm trying to find, is equal to opposite over adjacent. So that would be 7.95 over 324. And now I'm going to do inverse tan, because remember, anytime you're looking for the angle, you're using inverse tan, or inverse of whatever your trig function is. So second tan, 7.95 divided by 324, and I get like 1.4 degrees. Whoops. And remember, that's an angle of descent for an airplane. Probably real tiny angles are what you're going to need for that, because a plane is not going to descend at a huge angle. Okay? If for this last problem you got something around, I don't know, 98.5, or I'm sorry, 88.5, if you got something like 88.5, what you did by mistake, whether you meant to or not, was find this angle. Okay, but remember, if you want angle of descent, that's actually an angle outside the triangle, which you can then put inside the triangle like that. Okay, let's look at number 16. A flagpole. So let me get my cool artwork back out again. Here's my flagpole. Okay, and it casts a 22-foot shadow. So down here, this is 22 feet. And the sun would be up here someplace. Okay. And the sun is shining down on the flagpole like so. Okay. And I know that where the sun meets the ground, now be careful about how you read this. The sun makes a 78-degree angle with the ground. That means that this angle down here is 78 degrees. Okay, sorry, I know that's a little hard to read. And what I want is the height of the flagpole, so I want this. So from that 78 degrees, the x is the opposite side, so let's label that. This is my opposite side. And the 22 feet, because it's right next to that 78, that would be the adjacent. The hypotenuse is where the sun is shining, and obviously we don't have a measurement for that. So once again, just like the last problem, we're working with opposite and adjacent, which is tangent. So I'm going to say tan of 78 is equal to x over 22. I'm going to get tan of 78 from my calculator. I get 4.7046 equals x over 22. I'm going to put that over 1. And then I will cross multiply, so I will do this times this. And then I guess technically you'd be dividing by 1, but obviously you don't really need to worry about dividing by 1. Whoops. Okay, I end up with 103.5. Okay. Now I'll admit, and I just paused it and double checked all of this, that seems awfully large for a flagpole. Like I said, double checking everything looks good. I think that maybe I just picked some bad numbers here. The 78-degree angle probably makes a big difference. So, yeah. Okay, so we have a 100-foot tall flagpole. It's a really tall flagpole. Let's check out 17. 17. We've done lots of problems like this one. Miles is 5 foot 6 inches. Now remember, you're going to have to convert that. That's kind of a mixed unit. Well, 6 inches is half of a foot. So instead of 5 foot 6, I could say this is really 5.5 feet. That's 5.5. Just don't make it 5.6. That would be incorrect. You could also convert it to inches. That would be 66 inches total. And he's looking up at a building, a crooked building. So he's 24 feet away. So there's your triangle. This distance here is 24 feet. And he can see the top of the building at an angle of 58 degrees. Okay. And I want to know the height of the building. Remember that for this one, I'm going to use trig to find this piece here. Okay? But then to get the bottom piece, to get the entire height of the building, I'm going to have to add on his height, which is the 5.5 that we had just a second ago. So looking at this triangle, if this is my angle, the 58 degrees, the x is the opposite. Okay, so this is my O. And again, the 24 is the adjacent. We've used tangent a lot, and well, I can't say that you're always going to use tangent. Tangent comes up a lot because there's not a lot of real life situations where we have this slanted measurement. Most of our measuring takes place left to right or up and down. So tangent actually is used probably quite a bit more than the others. So I would say tan of 58 this time is equal to x over 24. It's going to be very similar to the last problem. Tan of 58 is equal to 1.6003. Equals x over 24. Put this over 1. And let's cross multiply. And I get about 38.4 feet.
I'm going to go out.
Okay, so again, that 38.4 really just represents this distance here. And then we need to add on our 5.5. So I'm going to say plus 5.5. And you end up with 43.9 feet as your final answer for the height of the total building. Okay, onward. In question number 18, there's a piece of information that I'm going to kind of take away from you and not make you worry about. It says in here that the spectator is 6 feet tall. And we've worked with problems like that. In fact, the very last problem was like that, where he was 5.5 feet tall. But in this problem, that's not really going to help us. And I'll show you why after we draw the picture, but I want you to ignore the fact that he's 6 feet tall. I didn't really take into consideration the rest of the problem when I put that in there. So, the Leaning Tower of Pisa. So, originally the tower was standing up straight, the foundation started to give way, and now it leans like this. Whoops. Okay, it doesn't curve. Let's try that again. Okay. There's the Leaning Tower. Okay? And I'll put the ground down here. Now there's a spectator over here looking up at the tower. And he can see the top at an angle of 53 degrees. And what I want you to do is kind of just imagine this was a complete triangle here, and that this whole angle is 53. Because like I said, his height is going to be complicated for us to work with. So we're not going to worry about that right now. Okay. And it also gives us that originally the tower was 179 feet tall. So over here, this is 179. And I think it says that he is 150 feet away, which means that this distance down here at the bottom is 150. Okay? Let me try that again. 150 down here. Okay, so the problem here is, oh, and then you're trying to find this angle. You're trying to find the angle that this makes with the ground. The problem here is this is not a right triangle because we have a leaning tower. And that's part of the reason that we can't use the height, because normally we use the height, you know, because the building is standing up like this and the person is standing up like this, so we can just add the height on. This time the height is leaning while the person is standing up straight, so their height's not necessarily going to translate to the same height at the bottom of the tower. So don't worry about the 6 feet. We're just going to kind of ignore that fact for now. Let me draw just the triangle here separately so that maybe you get a better idea of what we need to do. Triangle looks something like this, and remember it is not a right triangle, which means we're not going to be able to use SOHCAHTOA. And I know that this is 53. I know that this down here is 150. I know this is 179. And this is the angle I'm trying to find. Okay? So, law of sines or cosines. Well, law of sines should work because I have a complete pair here. I have 53 degrees across from 179. But when I go to set up my other proportion, I would either need to know this side, and I don't really have a way to find a missing side if I don't have it already, or I need to use this angle with the 150. Now, here's the nice thing. I do know, or let me say that again. I could find this angle using this proportion, okay? And if I were able to find that angle, that would help me know this angle because I could subtract from 180. So let me say that again because I think I was confusing there. And I apologize. Again, I have a toddler climbing all over me. I'm going to use law of sines here because I do have a complete pair, but I can't set up this as my other proportion because I don't have this side length. I could solve for this angle because I have this side length. So I'm going to find this angle first, and then because this is a triangle, I know these three have to add up to 180, and I can subtract. Okay? So let's give this a shot with law of sines. Let me see if this would work. Give myself some space here. So if I was going to set this up with law of sines, I would do, whoops, that's not what I meant to do. I would do sine of 53 over 179. Equals sine of x over 150. And actually, I'm not going to call it x because I already labeled my other angle x. Let's use a different letter. Sine of y.
This shirt is wet.
Okay, so here I would do sine of 53 times 150 divide by 179. When I do that, I end up with 0.6692 equals sine of y. And remember, anytime I end up with something equal to the sine of something, I can use an inverse to get that angle. So I'm going to do the inverse sine of that decimal, and I get 42 degrees. Okay? Remember, though, that's not my final answer. That 42 degrees represents this angle up here. So this angle is 42. So now I know if this is 42 and this is 53, I can add those together and subtract from 180. So I'm going to do 180 minus 42 minus 53. And I believe that comes out to be 85 degrees. So this angle down here that this is making with the ground is 85. And that seems reasonable because 90 degrees would be standing up straight. So 85 degrees is leaning by about 5 degrees. And I think that does make sense. Okay. Let's go on with this last problem. All right, let's take a look at this last one. Whew. Okay, 2 ships leave a harbor. This is very similar to your warm-up over the last couple of days. Okay, so 2 ships leave a harbor. Here's your harbor. Okay, and one is headed this way and one is headed this way. And it says they have an angle of 140 between them. So here's 140. Okay. The first ship is traveling 26 miles an hour. Now remember, though, that 26 miles an hour does not actually give you that distance. If you're going 26 miles an hour for 3 hours, you would do 26 times 3, which is going to be 78. And that will be your side length over here. That's the distance that the ship is actually traveling, is 78. And over here, if we're going 34 miles an hour for 3 hours, that's going to be, let me just double check that, I think I know it. Yep, 102. So this is 102 for your side length over here. And what I am looking for is this distance up here, is the distance in between them. Okay, so once again, not a right triangle, so I'm looking at law of sines or cosines. And because I don't have a complete pair anywhere, the 78 would go with this angle up here, the 102 would go with this angle up here, I'm going to use law of cosines. Okay, now the good news is, though, this is not one of the more difficult law of cosines ones. Okay, this one you shouldn't have really any trouble with. So I'm going to make this side A, because that's the side I'm looking for, which makes this angle A. And then remember, these are B and C. And if I plug into my formula, oh, let's see, I'm out of space there. Here, I'll slide up like that. If I plug into my formula, that would give me A squared. Okay, somewhere in there I hit pause. And to be honest, I'm not really sure where it paused, because I kept talking and then looked down and realized it wasn't recording. So sorry about that. Let's see where we maybe left off. So I labeled side A here because this is my variable, which makes angle A straight across from it. B and C are my other 2 sides. And then I took those values and plugged them into the formula. And then from there, this whole thing, because this is all numbers, can go straight into your calculator. Okay, so again, I don't know how much of that was repeat. I don't know when I hit pause, and I don't have an easy way to find out. So sorry if I just had to repeat myself a whole bunch. Okay, out of the calculator, I get, whoops, A squared equals 28,677. We'll say 30. And since that's equal to A squared, from there I would take a square root, and I end up with about 169.3. Which means that the distance between these ships is 169 miles. Which, looking at the numbers here, 78 and 102, the 169 for that distance does seem to make sense. Okay, the other thing we have to cover on this test review is the unit circle. And I'm not going to take the time here to go through the entire unit circle because you should have a filled-in copy in your notes packet. If you don't have it or you want to look at a clean copy, just Google the unit circle and you'll find tons and tons of images that are totally filled in unit circles. Okay, so you can use that to check and then just try to practice finding exact values. And there was a question, I think number 14 on the previous page, that was all exact values. Okay, so those are the types you're going to need to know how to do. Good luck, and feel free to email me if you have any questions.